Hey everybody, and welcome to the third episode of the 3D Pong Clone tutorial series in Unity. In this episode, we're going to be adding movement to our ball. But before we do that, we're going to go ahead and make a few changes to our scene. First, let's go to our Player 1 goal and change the scale along the x-axis to 100. And we'll do the same for Player 2 goal. Then, let's go to our directional light and change the intensity to 3. This will make both of our player paddles easier to see. Then, let's also go up to our main camera and change the position along the x-axis to 0. Next, let's go ahead and make a few changes to our ball. So we'll go to Ball, and we'll go to Add Component, and we're going to add a rigid body. Then, inside of here, we're going to change our angular drag to 0, and we're going to uncheck Use Gravity. Also, in the Constraints section, we're going to freeze the position along the z-axis and the rotation along all three. Then let's go ahead and create our script for the movement itself. So in our scripts folder, go ahead and right click, we'll go to create and C# script. Let's just call this ball movement. Then let's open it up. Now, once it's open, what we're going to do is go ahead and type out the whole script, then we'll go back over it at the end. First off, above our void start method, let's go ahead and create a few variables. First, we're going to create a private float called speed. Then we're going to create a private vector3 called direction. And another private vector3 called start position. Then what we want to do is make this private float available to us in the inspector. So if you remember, inside of square brackets, we're going to say serialized field with a capital S and F. Just like that. Next, down in our start method, which is called before the first frame update, what we want to do is say start position equals transform dot position. Then below that, we're going to say launch with a capital L, open and close parentheses, and a semicolon at the end. And some of you may recognize this as a call to a method, and that's because it is. This is actually a call to a method that we'll be creating here very shortly. Next, down in void update, which if you remember is called once per frame, we're going to say transform dot position plus equals direction times speed. And below that, we're going to create an if statement. And inside, we're going to say input with a capital I, dot get key down with a capital G, K, and D. And in parentheses, again, we're going to say key code with a capital K and C, dot space with a capital S. Then, inside the body of our if statement, we're going to just call the launch method again. Just like that. Now, below this, we're going to say debug with a capital D, dot log with a capital L, and in parentheses, we're going to type direction. Next, let's go ahead and create our launch method. So, just below our update method, we're going to say private void launch. I'll spell it just like we did above. And inside of here, we're going to say transform dot position equals start position, being the variable we typed earlier. Then below here, we're going to say float x equals random dot range, and in parentheses, we're going to say 0, comma, space 2. And just outside of that, we're going to say is equal, being two equal signs, to 0, question mark, -1, colon, 1, and then a semicolon at the end. Then we'll go ahead and copy and paste this down below. and change it from float x to float y. And just below that, we're going to say direction equals a new vector 3. And in parentheses, we're going to say x comma y. And outside of that, we're going to say dot normalized with a semicolon at the end. Then we're going to add another method, which is already built into Unity, called onCollisionEnter. So we're going to say void onCollisionEnter with a capital O, C, and E. And then in parentheses, we're going to say collision with a capital C, space, collision again with a lowercase c. Then inside of the body of that method, we're going to say contact point with a capital C and P. We're going to call it contact. And we're going to set that equal to collision dot get contact with a capital G and C. In parentheses, we're going to say 0, or the number 0, I should say. Then below this, we're going to say vector 3 normal is equal to contact dot normal. Then below this, we're going to say direction equals a vector 3 dot reflect. In parentheses, we're going to say direction comma normal. And that's it. So let's go ahead and go back over this. So first we created a few variables, one being a private float called speed that we made available to us in the inspector. Then we created two private vector 3s. One called direction, which will be the direction that we want our ball to travel in, or that it is traveling in. And then another one called start position, which is going to hold the starting position of the object that we attach the script to, being our ball. Then inside of our start method, which is only going to be called once before the first frame update, we set start position equal to the object's current position by saying transform dot position. And if you remember, transform here gets the transform component attached to this game object. This game object being the object that the script is attached to. We could have also said this dot transform dot position, but that is unnecessary. Then below this, we had a call to our launch method. Next, in our update method, which is called once per frame, we said we want to take our object's position and add direction times speed. Speed being this float value up here, and direction being the vector 3 that we created earlier, which doesn't yet have a value. Then we said if the player presses space by using this getKeyDown method inside of the input class, which is similar to getKey, but whereas getKey would run each frame that the key was held down, getKeyDown will only run once when the key is initially pressed. So we said when the space key is pressed down, we want to run our launch method. And you'll see why we did this in a bit. Then we said debug.log direction. And debug.log, you can think of it as like an equivalent to console.writeLine in a console application. But this is for Unity. So we basically said that we want to print direction to the console. Then we finally created our method called launch, which takes our object's position and sets it equal to start position. Then we created two private floats being x and y. And we can actually go ahead and change these to ints. And these two integer variables will be set to either -1 or 1 randomly. And we accomplish that like so. So this random class is for generating random data and is part of the Unity engine. Then this range method returns a random integer number between a minimum inclusive number and a maximum exclusive number. So, because 2 is exclusive, it is not included here. So our range is only going to be from 0 to 1. And because it is an integer value, it can only be 0 or 1. Then we said if this value here is equal to 0, then we want to set it to -1. And if it is not equal to 0, then we're going to set it to 1. And we did that by using the ternary operator. So essentially, int x and int y will be set either to -1 or 1, and should have a 50-50 chance of either. Then we set vector3 being direction equal to a new vector3, which takes this x value and this y value. Then, because we didn't specify a z value, it's just going to default to 0. So direction will have an x and a y, but no z value. Then we added this dot normalized, which returns this vector with a magnitude of 1. And this is just going to help prevent any issues, at least for our specific case. But we're not going to go into a whole lot more detail about that in order to keep things simple. For right now, just know that adding this dot normalized returns the vector with a magnitude of 1. Then, down here, we utilized another method that was already a part of Unity, similar to these start and update methods. Except this one's called onCollisionEnter, and if we mouse over it, you can see that onCollisionEnter is called when this collider, or rigid body, has begun touching another rigid body or collider. So, when the object that our script is attached to, if it has a rigid body or a collider and it collides with another one, then this method here is going to run. And this is something I'm sure a lot of you will be using quite often in a lot of different game types. Then, for a parameter, it needs an instance of the collision class. And we went ahead and named our parameter collision. And if we mouse over the collision class here, it says that it describes a collision, which basically tells us that it has a lot of different things within it that help describe the different parts of a collision. And feel free to look into this on your own time if you're more interested in what options you have available to you within the Unity engine for working with collisions. Then, inside of our method, we worked with a struct called contact point, which describes a contact point where the collision occurs. And this is somewhat similar to collision, except this one here is for describing a contact point specifically. And we called this contact, and we set it equal to collision.getContact at index 0. And the getContact method here gets the contact point at the specified index. Now honestly, a lot of what we have here, especially in these 3 lines, is fairly complicated, and we're not going to dive into a whole lot of detail about it. If you want to learn more about collisions, contact points, or just some of these methods like getContact or reflect, I highly encourage you to look it up on your own time and learn a little bit about it, even if it's just the basics of what it does, when can you use it, and how to implement it into your own code. Just so you know what's available to you and when you may or may not need it. And that goes for anything, especially when you guys start working on your own applications. I promise you, professional programmers who've been working on things for 40, 50 years, even if it's all in the same language, they do not know every single method and class, etc. available to them. What's way more important as a programmer is being able to utilize resources available to you whenever you come across a problem, whether it be books or the internet. Just find a solution, implement it in your code, and get it working. Then go back, maybe figure out a little bit about what it is, what options it gives you, and how you may or may not want to implement it in other applications. You don't always need to know every intricate detail of every little thing, especially if you may never use it again. And you'll hear this a lot from many professional programmers. Oftentimes, being able to look up solutions to problems you have, being able to implement them in your own applications, is vastly more important than knowing and memorizing every little thing. And it's honestly something you're going to be doing a lot of. So it's best to just accept it and move forward. But let's continue on here. So basically, this gets the contact point at the specified index. And we just went ahead and implemented index 0 for this value here. Then we created another vector3 called normal, and we set it equal to contact, being our contact point here, dot normal, which is the normal of the contact point. Now, once again, if you don't know what a normal is, feel free to look it up, but to give you a brief description, It's basically a line that is perpendicular to a given object. Then we wanted to set direction, being the vector 3 we created, equal to vector3 dot reflect, which just reflects a vector off of the plane defined by a normal. And this takes a direction and a normal. So basically what this line here does is allow our object that we attach the script to reflect off of a surface. And like I said, you don't need to know all the little details of this. For right now, just copy it into your code, and then if you feel it's going to be important to something you're going to work on in the future, go back and look into it a bit. Anyways, go ahead and save what you have, and let's go back into Unity. Then all we're going to do is drag our script onto our ball, and we're also going to add the console window here. So let's go up to Window here at the top, we'll go down to General, go to Console, and then you can just drag this wherever you want. I'm going to put mine next to this Project tab. And I did have a couple of you ask how I got this layout, and basically all you have to do is go over here to Window, go to Layouts, and I believe it's this 2x3 one. Then all I did was move things around a bit and scale them a little based on how I wanted it. Then let's go to our ball object, and for our script we're going to change speed to 0.1, and we're good to go. So now if we hit play, you can see that our ball moves in a random direction, moves at a consistent pace, and it bounces off of objects just like we would expect it to. And if we hit space, we can reset the ball and send it off in one of 4 random directions. Also, the ball's direction is displayed right here in the console, and if for whatever reason your console looks like this, just click this collapse button here at the top, and this will make it so that duplicate text appears on the same line, and it simply displays how many times it's been printed to the console. Anyways, that is it for this video. In the next video, we'll make it so our ball resets when it hits either the player 1 or player 2 goal, we'll have the paddles reset with it, and we'll make it so our scores for player 1 and player 2 adjust accordingly. So, anyways, don't forget to save your progress. Thanks for watching, and I'll see you in the next one.